Okay, so what was your question?
Do the different colors on the wires mean something different?
Yes, they do to us. The electrons
Okay.
don't care. Um, right? The color on the wire is meaningful to us, and we choose to make it meaningful. And we'll go into what the meanings are. There are a couple of conventions that I've honored, and then I've made up some of my own. Um, so um, there's a color code um, that you can use by number. It's black, brown, red, orange, yellow, green, blue, violet, gray, white, which we can go over again later. But
Okay.
that's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so let's begin at the beginning. Take your wire stripper. Okay, so you're going to need these blue things as well. The cutters and the pliers. Yep, right on. Okay, but we're going to start with the wire stripper. Now, if you
Should
look
I
at
have
the
the
wire
blue mat
stripper,
out or not yet?
what's that?
Should I have the rubber mat out or not yet?
Either way, doesn't matter.
Okay. Gosh.
At the moment, it doesn't matter. Okay, so
Okay.
you're going to take a piece of wire. Are you seeing this all right?
Yep.
Okay, now in the back of the wire cutter, right here,
So sorry, let me grab a piece.
yeah, yeah, doesn't matter what color.
Okay. All right. In the back of the wire strippers.
Okay, so in the back of the wire stripper, so if you look, let's see, where is this? So if you look here, there are a bunch of numbers.
Hmm.
Um, and if you look at the back here, there's a cutter.
Hmm.
Okay? This is
Yep.
known as a bypass cutter because the sides go next to each other like scissors. The blue
Gotcha.
cutter that you have is a nip cutter or a closure cutter. Um, but we'll get to that later. I'm talking too many things here. I'm going to confuse you. Let's not do that. All right. So we're going to cut the wire with the back of the wire stripper. Right.
Ta-da!
Okay. Now, look at those numbers on the side of the wire stripper, and one of them says AWG. That is American wire gauge.
Is that just like the standardized?
So it's
Like,
it's a size thing, but it's just a standardization. On the other side,
yeah.
your wire strippers might have millimeters, which is a whole lot easier to understand.
Yeah.
But the wire that we are using is American wire gauge 24. And you'll notice that as the numbers get bigger, the holes get smaller, just
Yeah.
to confuse things. Um, so 40 gauge wire is almost hard to see, and 1 gauge wire is as big as your thumb. Okay?
Yeah. What are those types of wires used for when they go that big?
Running huge currents through them. Remember, we talked about the conductance being proportional to the area?
Oh,
Right.
yep.
So if you want
Yeah,
to
that
run
makes sense.
really high currents, like for welding, you'd use a number one or number zero or number double zero because they go bigger than that and they ran out of numbers because they started somewhere. Anyway, all right. So now, you want to take this wire and put it in the hole that says
For
24.
0.24. Okay.
Yep. Okay, now, very, very important. You want to hold the wire perpendicular to the, oh, I'm blocking it with my hand. Let me do this. Video, video settings, can we not reverse, please? Because I'm getting really confused. Okay, there we go. So you can go away now. Okay, now I can see what I'm doing. Um, all right, so you want to hold it perpendicular, sticking out of the wire strippers. Okay. And you want to close down firmly, but not super firmly.
Mhm.
Okay. And that should cut through the plastic, but not cut into the wire. And
Oh
then,
yeah.
and then you want to pull.
Oh, I jumped the gun. Hang on.
Yeah, that piece of wire you
Okay,
have is a
perfect.
little short. It's a little hard to pull, but that's okay. If you want more wire, just cut another piece.
Yeah, it's perfect. Okay. Perpendicular. Whoa.
Excellent. Okay, so this is known as a wire stripper. We are stripping the insulation off of the wire.
So cool.
All right, now, things that you shouldn't do. Do not put this in some other hole than 24 for this wire, but
Okay.
also don't do this. This way. Don't pull down like this. You see how I've got it not sticking out perpendicular?
Oh yeah.
So if you do that and you have sharp eyes, you should be able to see that the wire is a little bit nicked now.
Yeah.
Right? That's bad for the wire. We're going through all of this process because we don't want the wires to break because we're going to put them in specific places. If you
Mhm.
nick the wire and bend it a couple of times, it'll break.
Gotcha.
Okay? So
Mhm.
perpendicular, always get the right hole, and you can use the back of the thing to cut. Okay, so now we're going to do a soldering station setup.
Okay.
Um, so if we look at what I've got here, let's see if I can get this to. Okay, I'm a little constrained by my stand, but you see the orange mat?
Yes.
That is a silicone rubber mat, and yours is blue, and yours also has a little parts organizer around the edge.
Yeah. That's super convenient. Oh, it looks like a ruler.
Excellent. And in blue. I try to get everything in blue for you.
I appreciate that.
You're welcome. Um, so then you'll notice that there is that fume exhauster above the mat. So the purpose of that carbon filter is to take stuff out of the air that would otherwise get into your body, which is kind of a carbon filter. Um, so we need that to be close to where we're working. So you're going to want that right over whatever you're working on, and you're going to want it no further than a hand span away, right? So no further than a hand span from fingertip to fingertip, and probably not any closer than a hand width. Um, and body position is going to count here because you're going to be bent over doing this. Um, so you want to move things to where they're convenient for you and don't worry about the camera so much.
I'll probably read fast. Completely figure out what I'm doing, but this seems good for me.
All right, it's a good start.
Are there different size soldering irons?
Yes. There are soldering irons for doing things like the frame around stained glass, which are much larger. And then
Mhm.
there are soldering irons for doing really small things. So they're smaller and larger, and there are ones that have a hole in the middle so that you can pull vacuum through it and suck things through. Um,
Oh,
so there's all kinds of soldering irons.
very
Um,
cool.
so if you look at the back of the metal part nearest your hand, you'll see there's a little, it's called a ferrule. Right? Do you see the little stripy part at the base of the, yeah, that. Right,
Yeah.
good. Don't touch it with your fingers. That's what you want to
No, I didn't. I didn't.
inculcate. No, 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 you did it you with the pencils, great. That
Oh,
that is a nut. And if that gets loose, the soldering iron will feel a little floppy.
gotcha.
And the way to
What did you say it
tighten
was called? A ferrule?
ferrule, Ferrule. It's a kind of a ring, really. Um,
Oh, gotcha.
it's a ring nut is what it is. So if that's loose, you want to tighten it, and you don't want to touch it with your fingers because you don't know if it's hot or not. Look at the front of your wire stripper at the very end of the jaws. There should be some teeth.
Yeah.
Okay, so you can tighten it with the teeth at the end of the wire stripper. Yep, just like that.
Oh,
And it
yeah.
screws in ready tighty if it's facing you. Okay, and then one last thing about the soldering iron is there's a little black knob about halfway up the handle.
Yep.
That is the temperature control. So if you want it to
Okay.
be a little bit hotter, you're going to turn that to the right. And if you want it to be a little colder, you're going to turn it to the left.
Gotcha.
And just as we were talking about Baby Bear last time, you want it to be just right. Um, if it is too cold, the solder won't melt. If it's too hot, it will turn the flux into carbon, which will make your life difficult. And I think it only turns like 270 degrees or something. I don't think it goes any
Oh,
more around than that. And if it's
gotcha.
hard to turn, there's a little screwdriver slot in it. Um,
Oh, that makes sense. Like, should I have it any more specific right now for like a starting point?
if you drive it all the way to the left and then drive it all the way to the right, you can figure out where the middle is. And since we're doing Baby Bear, you want it in the middle.
Gotcha.
And I don't know where the middle is based on the slot of that. You want it about in the middle. Because we're using lead-free solder, we may need to turn it up a little bit because it melts at a slightly higher temperature than leaded solder.
Gotcha. That seems good. It's about halfway. Maybe a little right justified, but
Okay. It should become pretty clear what we need to do with it once you start messing with actual solder. Okay, so now that thing in your hand is a fire hazard. So you should
yeah.
never leave the house with it plugged in.
Okay.
It's one thing if need to go get a drink of water or whatever, or go root through the supplies. That's fine. Um,
Mhm.
you want to make very, very sure that it is not plugged in when you leave the house or the apartment or whatever you call it.
Yeah, makes enough sense.
And once again, never grab the metal parts with your hand because
Mhm.
that'll hurt a lot and you'll probably need to go to the hospital to get your burns dressed, depending on how hard you grab it. Okay, so now
Yeah.
we're going to practice. You're going to take the end of the thing, and that'll be the tip of the soldering iron,
Okay.
and you're going to wipe it on the sponge. You're going to put it on the sponge and pull it toward you, right? Like that. And then flip it over and do the other side. Right. That's what you do every time you use the soldering iron.
Okay.
So you wipe one side, wipe the other side, then do the soldering that you need to do, and then wipe it both sides and put it back in the stand.
Gotcha.
And the reason for
And it's
that, oh, yeah,
every
go
wet
ahead.
the sponge every time, right?
And you have to wet the sponge every time. Dry sponge isn't going to help. But you also
Gotcha.
don't want a soaking wet sponge
Yeah.
because that'll just take the heat out of the end of the soldering iron, boiling off all the water. It'll still steam, but that's what we want. It's kind of like steam cleaning it, actually. Um, so you wipe it on the sponge and do your little soldering thing, and then you wipe it on the sponge and put it back in the stand. And the reason we do that is that the flux, which we'll talk about in a second, if it's just sitting there on the iron, it'll burn away and turn into carbon, and then the iron won't work as well.
Mm, gotcha.
So we want to keep it clean. Okay, so before you plug in your soldering iron, you are going to put your safety glasses on, and you're going to leave it in the stand, the soldering iron in the stand. Never leave the soldering iron anywhere else but the stand.
Turn iron sand, safety
Yep,
glasses on, air
good.
cooled back.
Good, good, good. Okay, now go ahead and plug it in. Okay, so what we want to do is we want to melt the solder, have it connect two things together, and then let it go solid.
Mhm.
Okay, in order to connect those two things together, we need them both to be hot. So we're going to have to think about where we put the iron and how long we leave it there. Think about which is easier to pour, which is thinner, hot honey or cold honey.
Hot honey.
Yeah, hot honey is easier to pour. And hot materials will diffuse better than cold materials, right?
Gotcha.
So
Yeah.
solder will flow toward the heat because as it moves closer to the heat, its runniness goes up. The molecules get more temperature, which means more kinetic energy, so they move toward the heat. So what you don't want to do is you don't want to have the iron and the solder on the same side of the thing that you are trying to connect. You want to have the iron on one side and introduce the solder from the other side, so it has to flow toward the iron. So it has to flow across the thing you're trying to join to get to the iron. Does that make any sense?
Okay. Kind of. I think I'm just going to like see it to like
Yeah,
lock
yeah,
it
yeah.
in though.
So we'll have to practice. Let me do a little cold demonstration here. Can you see this okay? Let's see. There we are.
Yep.
Okay, so let's suppose that I am trying to melt some solder onto this thing.
Yep.
So I'm going to bring the solder in. So I'm right-handed. I'm going to bring the solder in from the left, and then I'm going to put the soldering iron with the flat down on the pad, and then I'm going to introduce the solder from the left so it has to flow across the pad to the iron.
Okay. That
Okay.
makes sense. Yeah.
Um, so um, that's what you're trying to do. Now, there's one other thing you have to do first, which is you have to get the thermal contact to be really good. Um,
Mhm.
have you ever cooked a veggie burger? Have you ever cooked a hamburger?
Cooked like a yeah, cooked like a beef burger. Yeah.
Right. Okay. Have you ever cooked one from frozen?
No.
Okay. Well, so imagine a beef burger frozen,
Hmm.
and you throw it in a dry frying pan. What's going to happen?
It's gonna stick.
It's going to stick,
Oh,
but it's also going to burn in spots,
oh yeah, yeah, yeah.
right? So for those two things, we need to put in some oil. And
Mhm.
we put oil in the pan for two reasons. One is to not let it stick, but the other is to thermally couple the burger to the pan, right? Make a lot of
Mhm.
surface contact by creating a liquid or adding a liquid,
Yeah.
right? So what
Yeah.
we need to do is we're going to put a little solder on the tip of the iron, and you can do that by kind of pressing it against the tip of the iron,
Mhm.
okay? And then you want to move it across. So let me demonstrate this. I will turn this on, and we'll see how noisy the fan is. I'm going to take my iron, which is here. I'm going to wipe
Mhm.
it on the sponge twice, once for each side.
Mhm.
And then I'm going to come down here and let's do it on a pad I haven't done before, right? So I need a
Mhm.
little bit of oil, right? It's not oil, we're going to use molten solder. So we're going to push this into
Yeah.
here and I can squish it underneath to get it to make contact. Now I have a little bit there, and then I can go and add more solder. And then you want to wait 1, 2, 3 to make sure the heat gets everywhere it needs to get. And only then
Mhm.
you let go.
Okay.
Okay. And you wait for it to cool down, partly so you don't burn yourself on it, but mostly because you want the crystals to form in the right form. Okay.
Right.
You want the right crystal size. You want it to cool rapidly, but in place. So you don't want to take molten solder joints and go moving them.
Mhm.
Okay. Make sense?
Yep.
So let's go ahead and try that. So you should find in your kit a a little board. It could look like that green one, or it could look like this red one, or it could look like this kind of not so colored buff one. Go ahead and take the iron
And on
and
both
wipe it on a
sides.
sponge, both sides. You can go faster than that. Just a swipe, swipe.
Okay.
Yep.
Okay.
Okay. And then find the flat part of the tip
Hmm.
and press that down onto one of the circular pads. Pads are the gold colored circles. Are they gold colored? Yeah, they're gold colored.
Yep.
Okay. Um,
Yep.
so now what you want to do is push the solder toward the iron until it makes contact and see if it melts.
It's not melting.
Okay. So what you
Oh,
might
yes, it is.
do,
Yes, it is.
oh, yeah,
Yep, it's melting.
it takes a little while to make good contact. Um, and then once you've got it melted, you have really good contact.
Yeah.
Okay, so you've melted all the solder you're going to melt. You hold it one,
Yep.
two, three, and then you take the iron off. And
I melted a lot of solder on accident.
yeah, good. And then you wipe it on the sponge and put it back in the stand so you don't actually burn yourself with it while you're looking at things.
Yeah. Can I try again? This one kind of sucks.
Oh, yeah, absolutely. You're going to be making lots and lots of these, so you should try again and see how it goes.
Okay.
Um, I will give you a link to the Adafruit Guide to Excellent Soldering, which will have close-up pictures of this.
Okay, perfect. Thank you.
If you have a hard time getting it to melt, you might try squashing the solder under the iron tip to get started. On the other hand, if it's melting just fine, then you're good.
Wait, say it again, splashing the solder under the iron.
So if you lay the solder down on the board and then squash the solder under the iron tip, then you can apply pressure on the iron tip to make good contact with the solder and it'll melt.
Hold on. I'm gonna clean this off. So I'm sorry, can you say the thing about putting the solder under again? I could not like hear it correctly.
Okay. So if you lay the solder out flat on the board, just do that without the iron. Just lay
Okay.
it flat on the board, and you can take your
Mhm.
finger and push it into the board.
Yeah.
That's what you're trying to do with the iron. You're trying to squish it down.
Okay.
Because it's soft, so when you squish it, it'll conform to the iron, and that'll make really good heat transfer.
Gotcha.
And you can actually try that on the silicon pad. You don't even need the board underneath it. Just take the iron and squish the solder down to the, yeah, not with your finger, with the iron.
Oh.
That was for demonstration purposes.
Okay, I was gonna say I didn't know what that was gonna do, but
Unless you
okay.
are a very interesting person, your fingers are not going to melt the solder.
Yeah, I had a feeling. Okay. So let's
So if you squish
push.
it down, it should just melt.
Yep,
Yep. Okay, so that's how you know your iron is hot enough. If it didn't melt, then we would want to turn up the iron a little bit.
gotcha.
And if it melted super easily and fast, we'd probably want to turn it down a little bit too, just to keep the iron tip clean. So yeah, experimenting with what happens when you just put solder on the iron is a useful thing to do. So feel free to try that. The solder is made of tin mostly, with a little bit of silver and a tiny bit of copper in it. Um, so unless you have a silver allergy, you're going to be fine.
No, I don't.
Um,
Okay.
so you see these little things here
Yeah.
where my cursor is? That's what you want them to
Yep.
look like.
Okay. So
Um,
probably a little bit more.
well, you don't have a wire in there now. You're just soldering on a blank pad. Um, so um, all right, so here, let's go through the slides here. So you're going to have a wire coming out. You're going to put
Hmm.
the flat of the iron down on the pad. Does this make sense?
Hmm. Yep.
Um, and then you're going to put the solder in from the other side. And you might have
Hmm.
to introduce a little bit just to make good thermal contact.
Hmm.
Um, but then when you're done, you're going to let it cool. And then eventually we'll trim the extra wire off. So that should look like
Okay.
these. It should look like little volcanoes. Um, so if we go to common soldering problems, let's look at this first, the ideal solder joint.
Okay.
Okay, do you remember meniscus from chemistry?
Yep.
We want a meniscus. We want the solder to adhere to the pad and to the wire.
Hmm.
You won't see much of a meniscus because you don't have any wires in there, right? It's
That
gonna
makes
it's
sense.
gonna flatten itself out that way. But this is what we're
Gotcha.
trying to do.
Okay.
Um, if you wiggle the wire while it's cooling, you'll get this kind of powdery look to it, and that's
Hmm.
not so good. Um, if you don't apply enough heat, it might look like this, or like that. We can get into more pictures of those. Um, and then if you apply too much heat, it might look like that, all charred and not connected.
Yeah.
Um, and then if you don't get it to stick to the pad, it'll look like a little droplet kind of hanging around on top and not a
Hmm.
meniscus with the pad.
Gotcha.
If you don't put enough solder in and you don't heat the pin enough, you'll get this kind of thing.
Hmm.
And all of those are non-meniscus type joints, and you want the meniscus joint because you want it really to be the same piece of metal so the electrons flow through it without any problem.
Yeah.
Okay? So
Mhm.
that's how we make good solder joints.
Hmm.
So now what you might do is you might take a wire that you stripped maybe earlier or make a new piece of stripped wire
Mhm.
and push it through the board so the end of it is facing up toward you so you don't burn the insulation.
Perpendicular. Okay.
Okay, so push that up through the board, so from the back of the board toward you,
Yep.
and then squash it down. It'll bend the wire, but that's totally okay.
Okay.
So you should have a little piece of wire sticking up at you.
Yeah.
Yeah? Okay, so
Yeah.
now what we want to do is we want to make a meniscus or a volcano of solder around the thing. And good for you for remembering your safety glasses. And go ahead and give it a try.
I don't know why I'm nervous.
Yeah, yeah. Turn the camera down a little bit so I can see where you're
Oh,
working.
right.
There we go. Thank you.
Dark, I have to move it back. Okay.
It's melting.
Yeah. Yeah.
Okay, then stop putting solder into it. Leave the iron there. Count to three,
One,
and then
two.
pull the iron away and let it cool down. Put the iron back in the stand, yes. And now look to see if it looks like a meniscus.
Kind of.
Good. Yeah. So once you've done 100 of those, you might feel like you kind of got the idea.
Okay.
And once you do 1,000 of those, then you'll really feel like you've got the idea. And you'll also have made ones that are really lousy, because that's just what happens. You'll
Gotcha.
begin to be able to find ones that are lousy and fix them, which that soldering guide goes over.
Okay, perfect. That's kind of cool.
It's a real power, to be able to take metal and melt it, um, and turn it into something else and connect electronically things to other things. Connecting wires is one thing, but how about we connect a component? So in your little box of things, there should be a little box of resistors. It's a small parts box. So pick one of those, um, one that's got a lot in it. Doesn't matter.
Yeah. Okay. The 1K seems to have the
Yeah,
most.
1K is a very common resistor.
Oh,
That's good. It was a good choice.
thank you.
And so proper technique here is to use the pliers. So if we take our little resistor,
Hmm.
we want to hold the pliers on the resistor side, like toward the body of the resistor. Okay, so here,
Okay.
right, you can see that the pliers are
Hmm.
right up against the body of the
Yeah.
resistor, right?
Yep.
What we don't want to do is we don't want to bend the pliers right against the body of the resistor because you can break the contact there.
Hmm.
So what we do want to do is bend the other side. So it looks like that. It is best technique to do it with the pliers. Most people don't bother. Mostly they bend them with their hands.
Okay.
So now look at that board. And if you look at the board on, oh, this one has the traces buried in it. Oh, I'm sorry about that. All right, well, you see the label in the middle?
Yeah.
So you want to put the resistor across the label in the middle so that one end goes in one row, in one column of holes, and the other one goes in the column of holes that's directly opposite over the center. This is a fairly standard place to put these things.
Okay.
And then you want to pull it all the way down to the board. So you're going to have to lift the board off. There you go. And then flip it over and squish it down on the pad so it doesn't fall out. You can also stop it falling out by bending the wires that are sticking up now so it doesn't fall out. Don't bend them too far.
Just bend them so like they kind of.
Oh, yeah, you don't want to
Okay.
bend them that far.
Oh, okay.
Just bend them a little bit to stop it falling out.
Oh, I see. I see. Okay.
Yep. Okay, so
Okay.
now you have two places to solder and you know how to do
Yes.
it.
I think.
Go for it.
It doesn't matter which one I do first.
No.
I'm gonna actually snip this guy because he's in my
Oh,
way.
don't. Oh, that one. Yeah. Don't nip
Yeah,
the
yeah,
ones
yeah.
you're
No, no,
about
no.
to
This one.
solder
This
yet
one.
because that'll be confusing.
Yeah. And I'm soldering like with the tall side up, right?
Yeah, you can
Okay.
solder the other one where it goes in, but that's kind of non-standard. You do that in places where you don't have access to the back.
Gotcha. Okay. All right.
The other purpose of the silicon mat is to stop things sliding around.
That makes sense.
You left the iron on there for a good long time afterwards. That's what you need to do. Unless you're doing a whole series of them and you're busy doing that, but um, wiping before everyone is a good idea.
Oh, that looks pretty good.
Right on.
I mean, obviously not perfect, but hey,
No
pretty
solder joint
good.
is perfect.
Okay. Oh yeah, that's a good one. Okay.
Right? This is the ideal solder joint is very, very rarely encountered. There's always going to be something that's going to be not quite, it's not going to look quite like an even meniscus all the way around or whatever. As long as
Yeah.
we're making good electrical contact, we're happy.
Yeah.
Now you can trim the legs off.
Okay.
We call them legs or leads or pins. Um,
What was the last one?
Pins like a sewing pin.
I should have left my goggles on when I was cutting it.
Oh yeah,
Now I
that's a
know.
good idea too.
Yep. I even took them off. Wow.
There you go.
This is crazy.
Excellent. All right, so we have one last thing for you to try, and then you'll be ready to go start building things. You want to practice
All
more,
right.
right?
Yeah, yeah,
But
for
you need
sure.
to practice more on the line with me all the time. Um, but okay, so in your kit, there should be some pieces like this. Uh, you see those?
Yeah, and the little kit. Oh, I see.
Yep, that's them. Now, one thing about the header pins is that you can choose how many of them that you want to use based on what you're using them for. So if you need five, you want five, take your little blue cutters and
Mhm.
cut the plastic in between them and watch that they don't go flying across the room. Um,
I mean, like, the heck on.
right, so count to some number and cut it in the middle. Doesn't matter. Yep, there you go.
What are these used for?
Beg pardon?
What are these used for?
Connecting boards to other boards.
Oh, gotcha, gotcha.
But we're just going to put them in the board first. Do you
Okay.
see this thing?
Yep. Were they one of the small one?
It doesn't matter. All right, so what we're going to do with that thing is we're going to use it as a fixture to hold these pins, to hold them in place and to hold them square to each other. So we're going to push these in long end first into the holes.
Okay.
Sometimes
And
it
it
takes
doesn't
a bit
matter
of
where.
force. Doesn't matter where.
Okay, gotcha.
Okay. And then
Mhm,
go ahead and put the board onto those pins.
mhm. Should it be like resistor side up or resistor
Yeah,
side down
resistor
underneath
side
it?
up is probably what you want.
Okay.
And you notice how it doesn't sit quite level.
Yeah.
So put some pins on the other side to make it level, right? You'll have to pick it up and squish these into the board and so on. But this is a typical arrangement where you have pins on one side and pins on the other side, and then you put the board down on both of them.
Oh, yeah. No, how about I do it the correct way before say yeah. Yep.
Okay. And then what you want to do is you want to pick this thing up and look at it from the side to see if the pins are V'd out from each other or V'd toward each other or both parallel to each other.
Um,
Does
like
that
the
make
two sets of pins?
Okay, so it would be like this. If the pins are, let me see how I can do that so you can see it. So if the pins are like this and they're parallel to each other, that's what you
Hmm.
want. If they're like that
Oh,
or
okay.
like that,
Yeah, no, they look parallel.
good. That is the purpose of that breadboard that you have underneath there, is to hold everything
Oh,
straight. So now how many
mhm.
pins do you have total?
10.
Okay, so now you have 10 solder joints to do.
Oh, cool.
So do those and ask me questions as you go, or just concentrate on it. That's fine. But we'll sit here and do that together.
It's actually funny for,
I think you want the iron to be a little more horizontal. So the flat part of the iron is in direct contact with the board. Yeah, there you
okay.
go. That'll give you better heat transfer. So you want the flat part against the board and then the side of the iron or the tip of the iron against the wire or the pin rather.
Do you get right on the fan when I do this? Just this part?
Yes, that would be a good
Okay.
idea. How do you like them so far? They look all right?
I think so. Hold on, let me put this down. I did the first five, and I'm thinking I should have gone left to right instead of right to left.
Well, you
Just
can
for
always
like,
turn it around.
well, that's true. No, I mean, like, I started on the right side. Yeah, I mean, I think they're looking pretty good. I definitely see the meniscus. It's funny, like, you take the iron, I mean, obviously you know this, but you take the iron off, and, like, almost immediately it goes from, like, clear and shiny to just, like, a little bit cloudier, like, as it's drying. Like, you
Yep.
can see it go from wet to dry. It's
Yeah,
crazy.
you're watching crystals form in real time.
That's insane.
Universe is an amazing place.
I know.
What happened there? Why did you cut it?
I didn't let the wire get hot enough. Or I'm sorry, I didn't let the like spot on the board get hot enough. So
Huh,
it was
okay.
like pulling
So
all on
it's
the,
stuck?
yeah.
Yeah, that's also typical. It's not something you want,
Okay.
but it happens often.
Okay.
If you want the solder to be very straight, because that'll make your positioning it easier, you can pull on it with a
Um,
pair of pliers and it will stretch a little bit and go very, very straight.
oh,
Oh, like don't even
oh
let
yeah.
it run through your hands. Just pull on it until it breaks.
Oh,
You
perfect.
see how straight it is?
Yeah, that's perfect.
Remember
That's exactly what I needed.
we were talking about yield strength before?
Yeah,
You're taking it past its yield point to get it into plastic deformation,
gotcha.
right? So it's mechanical engineering. We come right back to stress strain.
That's everything's connected.
Yep.
That one was not good.
Good. Why is it not good? You want to make sure that you make some bad ones so you can learn from them.
It pulled all on one side. I'm not quite sure what the fix is, but I will give it a try.
Right. Try something and see how it works.
Something you don't know. Having a much harder time with it these times for some reason. I think I got cocky.
Well, also when you've tried a solder joint, the flux burns off and coats it with carbon, and it makes it hard to make a solder joint over top of it.
Oh, okay.
So the metal is going to try to bead up on the surface. So we want to make it make contact to it. It's called wetting, like water wet. Um,
Okay.
and that's how we get the meniscus. But we have to break the surface tension. So we use a chemical called flux, which just means flow, so that you can break the surface tension so it moves where you want it to move. And flux was originally made from tree sap. Um, and I think now it's all synthetic, but it may still have some tree sap in it. And where, pray tell, is the flux coming from?
What? Sorry, what was the question?
Where is the flux coming from?
Temperature? The solder?
The solder itself is a tube. And inside the center
Oh,
of that tube is some of this tree sap stuff, which is why you get a little puff of smoke every time you melt it.
yeah.
And it's also why you want to wipe the soldering iron off after every move, um, because the flux, you think about it as tree sap, it's going to burn off and become charcoal. And charcoal is not good for surface contact.
Oh, gotcha. Okay, I'm content with all but one of them, and I
All
still have
right.
to fix the one.
That's really very good. Um, okay, so now you can take the board with its pins attached off of the breadboard. And the way you might need to do that is get a screwdriver underneath it. You might be able to pull it out by hand, but don't break your fingernails doing that.
Here we go.
Yeah. So now if you wanted to connect that to another board, you would put it on the other board and then solder the other ends of those pins.
Gotcha. I can't wait to show Matt when he gets back today.
Excellent. Also, the pins will slide in the plastic a little bit, that black plastic. So if you grab them
Yeah.
with a pair of pliers, you can push them up and down.
Oh, okay. I think I will cut this one.
So how did it go? What do you think?
Um, I think the angle is a huge thing, and I think you're right. I was holding it a little too high because the one where I had my elbow like all the way up, like a weirdo, like kind of sucks.
Yeah, yeah.
But the other one's like, I'll send you a photo because I don't
Yeah,
think you'd
yeah.
be able to see them that
Oh
well.
yeah,
Like
those look pretty
these
good
five,
from what I can tell from the
yeah,
screen. Yeah.
yeah, these five, I'm like actually like am I like really good at soldering off the jump?
Good, good, good. Yeah, yeah.
Yeah. I think it also gets a little harder doing the two next to each other
Right.
because you mess up the first one and then it like spills over. You're like, no, 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 no. So a couple of the other ones are a little rough. But these five, I'm like, wow.
Yeah. Great.
And I feel like the resistor one came out really good too. Well, I mean, maybe not really good. Maybe that's like overselling it, but like
Really
pretty
good
good for
for
a
a
first
first
try.
pass. Yeah.
For a first pass, yeah.
So if you want to hold components on and you don't have some other way to do it, you can use masking tape.
Oh, really?
Yeah, masking tape will work. Scotch tape will melt. Um,
Okay.
but masking tape, even the like blue temporary kind will work. Um,
Okay. Oh, perfect.
and then if you want the pins to be perpendicular, you can kind of position them by hand and with the tape, um, and get them working that way.
I feel like this is like a pretty good first go.
Yeah, yeah, great. Well done.
Thank you.
So you had asked if people who weld are also good at soldering.
Yes.
And the difference is really a matter of scale, right? Typically welding is done on larger objects. If you are welding small objects, you might be good at soldering. But the skills are in
Oh,
some ways not directly transferable.
gotcha. Yeah, I can see that. Wow.
So next step is to start, practice some more. It'd be a good idea. But
Yeah.
and then look over the instructions for building a Stella 1.2 and see what kind of questions you come up with before you go trying to put it together. Um,
Okay.
and then start trying to put one together. This is why I give you parts for three of them.
Yeah.
Right? Start trying to put one together, and then you'll come up with things that you need to fix, and then we can talk about how to fix. But that's enough we've covered enough that I don't want to overload you. So there's a couple of ways to get rid of solder, which we'll talk about next time.
Okay.
Or
Sounds good.
not get rid of, but remove some of.
Multimeter?
Yeah, you're going to need a multimeter.
Alrighty.
Obviously, you need wires to connect to this thing. Um,
Yeah.
so you probably want the ones that you have in your hand that are pokey at the end. And you want to put the black one into where it says COM for common in the center of the bottom.
Oh, yep.
Those are called shrouded banana plugs.
Does
Oh,
the
there's a
I
cover
think I
on.
have the wrong one.
No, no,
Hang
you
on.
have the right ones.
No, this one I need, I think.
Oh, okay. Well, the other ones should go too. There might just be a little cover on them. Yeah, pull the cover
Oh,
off. Yeah.
that'll do it. Okay.
Okay, and then the other one you're going to put into where it says auto V ohm uh capacitance hertz microamps and so on. There's a lot going
Okay.
on there. Okay.
All right.
So we are going to let's see. We're going to turn it on to auto. So you twist the dial. So
Okay.
it goes from off to auto.
Uh-huh.
Okay. And then you touch the ends together, and it should beep. However, it beeps really quietly. That's my complaint with this meter, is that it beeps really quietly. And I have the wrong probes on here. So I'm going to switch.
Think it beeped. Will it beep more than once if I keep doing it?
It should beep continuously,
Okay,
if
then
you
it is
if you
not
hold them
beeping.
together.
Okay, then
Um,
it's not beeping.
it's a really, really quiet beep. Yeah, okay.
Um,
So you should see something like this on the display. It should be, let's see, something in the zero range.
oh no, it just still says auto.
Oh, okay. Um, are there covers on those tips?
Yes.
Yes, there are covers on those tips.
Okay. Oh. Oh.
Yeah, well, it's a good
Oh.
thing that it didn't beep.
Yeah. Yeah, I do not hear the beep, but I see the numbers changing.
Okay, so if you hold it up to your ear,
Oh, I hear the beep.
yeah, yeah. Sorry about
Yep.
the quiet beeper. It
No,
was
no, no, you're good.
otherwise a perfect meter. Um, okay, let's do this for clarity. Um, turn it from auto up to V and up to omega. Omega
So,
is ohms, which is the unit of resistance. So if you touch them
yep.
together and hold them together, that should go to zero or nearly zero.
Oh, yep. 0.006. Oh, zero
Right.
zero 0.003.
Right. So notice that it's kind of wandering around.
Yeah.
It depends on how well you press those two pieces of metal together.
Oh, yeah.
And because we live on a planet with oxygen, oxygen lands on these things all the time. So you might have to press through the oxide layer in order to get good contact. That's going to be
Gotcha.
important later when you're buzzing things to make sure that they're working, because you can get a false negative if you're not pressing hard enough.
Oh, okay, okay.
So go ahead and poke the little board that you were working on
With both of them?
with both of them.
Okay. Am I still on ohms?
You should still be on ohms and it should go beep if you touch two things that are connected to each other. Or you can put them across the resistor and read the resistance value.
Oh, yeah. 0.992, which is almost 1,000.
Right. There you go.
Okay. Matter which, oh, let's see. No, it does not matter which side is which. Cool.
Right. Okay, so now you have that resistor soldered in there.
Yep.
Um, the pads on one side of the label and the pads on the other side of the label are connected, not across the label, but the pads are connected to each other. So you should
Yeah.
be able to see the same resistor, but not by poking in holes that are near the resistor, but not the ones that the resistor is actually soldered into. I'm not
Um,
explaining that well.
so like the holes next to where I have the resistor soldered into.
Right. At,
Oh yeah.
yeah,
Yeah, 1,000. Yeah, 0.994. That's
right. So now you
crazy.
can see which pads are connected to each other and which pads are not connected to each other by poking some adjacent pads and seeing if they're connected.
Yeah. Oh yeah, because I moved two over and it's 0. That's cool.
So inside that little red board, there are hidden wires, and you
Uh-huh.
can figure out where they go by poking two different holes and seeing if they're connected or not.
Uh-huh.
So
Oh,
that's known as buzzing a circuit to figure out what's going on.
oh, neat.
The proper term for that is continuity check.
Oh, gotcha. That makes sense. Oh, well, thank you so much.
You're very welcome.